Oh, yes. Yes, there we are. Okay, great. Here we are. So, hello, and welcome back. I'm AJ O'Neill. This is Beyond Code Live, and we're doing a little study sesh. And what I have here is the real Rust for Rustaceans book. As you can see, I have purchased it, and I also have got a little bootleg copy. So I was actually thinking that maybe there was a free web version or something, but then when I typed it in, the top hit was, some Russian website with the book. So, anyway, if I find some stuff in here that I want to share and highlight, I'll just, put this up so that we can discuss it for anybody that wants to do that. And this is also going to be office hours, so feel free to interrupt with questions. I'll try to keep an eye on the questions here. I see we've already got some people joined in. Welcome. But this is, this is going to be, I think what I'm going to do is, well, we'll find out what I'm going to do. I don't know what I'm going to do yet, but I think what I'm going to do is I'm going to read from the book. I'll read to myself a little bit so I can read quickly. Maybe I'll say some things out loud. Maybe I'll make some comments. But the purpose of me reading this book is because we're doing a book review at the Rust meetup this month on this book. And I wish I gave myself a little bit more time to get through it because I haven't even started yet. This is study session number 1 for me. But the purpose is, for me personally, is just to become a better software engineer. See if there's some patterns that I haven't thought about that I can learn here. And there's 2 things before we get into that. One, I need to get myself a nice cold Mr. Mountain Dew from the fridge because the one I have sitting here is warm. The second is, oh yeah, I'm already getting trolled in the Discord. Let me go ahead and give a link to the Discord in case anybody else wants to come join in on the Discord and troll me properly. We're all friends here. All right, so yeah, if you want to come into the Discord and troll me properly, there we go. And then one thing before we get started, because this conversation just got started in Discord. Let me pull this over. Conversation just got started in Discord right before I pulled this up. So I'm going to do this in a language agnostic way. But we were talking about, let's see, puzzle solving aspect, 100% agree. I love the puzzle solving aspect of programming. There was a time in my life when I was around college people. I don't know if I was still in college or not, but I would solve people's homework for fun, not to give them the answer, but just for myself. Let's see, that's what, hot plate is one of my favorite problems, just because it's deceptive. It's simple, but it's deceptive as well. Anyway, compare 2 strings and see if they were anagrams. You might want to do this in a loop, but nobody likes that. I don't know why you do that in a loop, but I'm sure that the conclusion you came to as to why to do that has some sensible reason. Go through each word once, putting the character in an object, and increment the sequence of the occurrence. Yes, I think that's reasonable. However, I'm going to give an alternate solution, which I have down here. Sorry for those of you online, you probably can't see this very well, but a loop is a loop is a loop. And I say people ought to learn for, right? Just learn loop. Don't worry about if it's a for loop or a while loop or whatever. So here's what we do. If we have a string that's of a certain length, if we divide by 2, we're going to get half that length. If it's not an even number, if it's got a 0.5, then it is going to not be, then the middle number is, or the middle letter is always the same for both. Well, potentially. Let's see. Could we have no? Oh, okay. Nope. I need to math.ceil here. Math.ceil. So we need to check that the middle letter is also the same. So that's why we need to check this. So what we could do is we could say we're going to start I at 0. We're going to start J at string.length. String.length minus 1 because we're going to be indexing into it. Sorry that I don't know how to get rid of this extra Chrome to make this better. Anyway, so what we could do is we could see, I'm gonna do it this way. This may not be exactly correct, but you'll get the gist of it. We could say if any given string is an anagram, right? Not 2 strings are an anagram, but if any given string is an anagram. Okay, so dang it, I can't. Can I close this out? No, that doesn't do anything. I wish I could get this more usable space because I'm going to post it here, whatever. So actually, no, I was right the first time because we just need to consider a single string. So we just say if stir I is not equal to stir j. Whoops, something went wrong there. then return false. So that's all that we need to do. And then we just say, I think the number of spaces here is wrong. That's okay, I guess. This should be 2. 1, 2. I don't know what's going on. Sorry. Then we just say increment I and decrement j, and then when they're the same, then we give up. I don't know what's the give up condition here. If I is greater than z, or j is less than, no, is greater than, but this is the halfway mark, right? Yeah. Or is less than z, then we could say break. I think that's essentially it. Sorry, the code's sloppy there, but I think that's more or less. I might have an off by 1 error, but what I'm saying is you just count from the middle. That's the point of this, is you just count from the middle, or you count from the ends to the middle, and that will give you if it's an anagram. Now, that said, let me go get a nice cold Mr. Mountain Dew, and we'll dig into the real task for the evening, which is Rust. But again, feel free to interrupt me, distract me. I'll answer questions. I'll be right back. Oh, let me put up I'm going to be right back here. I'm going to put, yeah, we'll put up that one. Okay, I'm back. Ish. Almost. Oh, sorry. Palindromes, not anagrams. Sorry. Yes. 100%. I'm with you. I got it. Yes. 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 So use an object, keep a counter. 100%. Yeah, I miss. My brain was thinking the wrong thing. Anagrams, mix it up any which way. Palindrome is equal. Okay, so this is, yeah, 100%. I'm just going to put do. All right, now let's move on to the good stuff here. So for copyright reasons / respect of the author, I'm not going to bring up everything on screen. I'll bring a couple of excerpts. One, I'll let you read this while I'm reading what I'm reading. But I thought this was really, really good. Just the introduction to the book in general. Let's see. All this. Okay, this I just thought was, when I saw this, I said, yep, that's what I'm here for. So this is the forward to the book. And this is why I have this book. It's to learn software engineering principles a little bit better. We could say, I'm taking a little time to sharpen the saw. Yeah. Okay, so I just see in the comments there, we got the same thing in the comments here that we were having on Discord. Basically, I was solving the wrong problem. You know, first thing, as a consultant, first thing I always try to do is make sure that we're actually solving the right problem, because I actually talk a lot of people out of hiring me because I convince them that what they want is not what they want. Because they think, oh, I'm going to hire a developer and then magic and then profit, you know? Step 1, hire a developer. Step 2, ... Step 3, profit. But a lot of times that's not really that's not what they want to do. So, okay, I'm looking in the introduction here, and I'm just going to, I'm just going to read myself, and I'll check up here. Occasionally. Oh, and a tip for speed reading is don't have an inner voice. The way that you can learn to get rid of your inner voice is to count out loud. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. So count out loud while you're reading, and that'll help get rid of your inner voice, because your inner voice slows you down, because you want to listen to your inner voice in real time. But if you want to read quickly, You just need to get rid of the inner voice so that you can get the information and not have an auditorial experience. I think there's certain people that have, I think the term is aphasia. I might be wrong about that. Aphantasia is when you cannot see things in your mind, and I think it's aphasia is when you can't hear things in your mind. So if you have the auditory version of aphantasia, then I guess you would be able to speed read pretty well naturally. Anyway. Within this book, I'm hoping to distill from years of my own experience writing Rust code into a single, easy-to-digest resource. Rust for Rustacean picks up where the Rust programming language, the Rust book leaves off. That's what I'm here for. Though well-suited for any programmer who wants to go beyond the basics. Oh, asynchronous I/O is in here. That's good. And embedded development. That's awesome. So we are going to have in March... We're going to have a Rust meetup that we're going to use. We're going to do the Blue Pill microcontroller. I've got the kits from right when Corona started. I bought a bunch of kits. Oh, we got an article, a comment over here. That's a slick way to solve the palindrome. Thank you. If only I'd been solving the right problem. Okay. I am gonna. I think this is valuable in terms of a selling point. Oh wait, this is different than the one that I have in my hands, isn't it? Introduction. The preface. Oh, okay. The preface is a little different. So I think this introduction piece here, this is, I'm going to let you read that because I have very little doubt that the author would be happy to have people read the introduction so that, you get a grasp of what is this book about? Is this book for me? Because my hope is that if you decide you want this book, which maybe you won't, but that's fine, whatever, but if you decide this is a book that you want to learn from, there's an affiliate link down below, benefit me, benefit the author. I prefer the physical copies, as you can tell, but anyway, I'm going to read through this right now. And I'll keep an eye on the chat. Oh, I gotta block the daggone bots. Oh man, there's a lot of people. Hello, a lot of people here just to watch me read. But feel free to ask questions about Rust, about JavaScript, about Go. Anyway. Project structure. That's when I think this is really important. Project structure. Let me highlight that. Project structure is important. It's because it's not, the code is only a quarter of the code. And having a well-defined project structure is a big part of it. Let me see. Programming Rust. No. Where's the Rust book at? Oh, here it is. The book. I think that if you're new to programming, period, I don't think that this is a bad book. So you notice it's very similar. The Rust programming language. This is not a bad book if you're new to programming. I don't necessarily recommend that Rust be your first language, but maybe for some people it's the right choice. But this book is meant to be, as you can see, this book is more, you're already a developer, you want to level up. Designing interfaces, yeah. Project structure. Interesting. Yeah, fuzzing and performance testing. Because at first when I saw testing, I was like, I think I get the gist of how testing is done in Rust. There's definitely some stuff I could learn because I'm not a big tester. I'm not a TDD or anything. But unit testing I think is pretty simple to understand. Macros. This covers macros. That is not. Whoops. Oh, that is not covered in the original. How do we go back? Can I tell it to go back, please? I don't want to hide the... No? No. Table of contents. Here we go. Back to introduction. Macros, yeah. It is not covered in the other book, and macros are generally a bad idea, I've come to discover. But Rust has them. I think the way that Zig does it is right. There's not a separate language for macros. Rust has a separate language for macros. It really bugs me. Okay, good. We've got a whole chapter on async programming. So just, yeah, that's right here. Role of an asynchronous executor and how it makes the whole async machinery come together. That's good, because I don't think most other languages have that. I think it's either you've got async in the language or you don't. Whereas Rust is I think the async bits in Rust are kind of like the, how to say this? Rust has different layers, and there's certain layers that are not, that you might want to do something different. If you're on a microcontroller, you don't want the memory management layer. And I think the async layer is kind of similar to that. What? The great powers that the unsafe keyword unlocks and the great responsibilities that come with those powers. And I'm not going to say thank you, Uncle Ben, because no, it's thank you, Psalms. Thank you, the psalmist. That's where Uncle Ben got it from. I'm going to scroll down here a little bit. Oh no, FFI? I guess we have to have it because we're interfacing with C libraries. Or because we want this to be accessible as a C library. Oh no. Well, what a cliffhanger. F in Maine. What next? I think that's actually a cute bit of humor. So I'm going to bring up the rustforrustaceans.com. Rustforrustaceans.com. Let's just see what is on here. I'm going to fit this over on this window. Huh. Oh, that's cool. Nice errata. I like that. That's great. Okay, I'm going into chapter 1, y'all. Excellent. We already covered 2 pages in, 20 minutes. I'm going to finish this in no time. This is going to work perfectly. Hey, I'm Houghton. I am, this is just a boring one, but thank you for joining in. But just so you know, I'm reading a book. And you can ask questions, but, and I recommend that you buy the book. I just found this on the first page of Google, this one. I mean, I've got the physical copy here, but anyway, I'll just highlight things as I come across things that I think are interesting. But, yeah. The precise meaning of various keywords and concepts. So this is precise meaning. I'm going to talk about that phrase when I do my rant on const versus let and var in JavaScript. It's important. Okay. Subtleties of ownership, borrowing, lifetimes. You can read this chapter from top to bottom if you wish, or you can use it as a reference to brush up on concepts you feel less sure about. I recommend you move on only when you feel completely comfortable with the content of this chapter. That's what he says here. Okay, so I'm not going to be doing that because I'm just trying to get through as quickly as I can before Thursday, and I've got 200 pages left, so meaning I'm on page 2. We're past the XIXX pages and on to the actual book here. Not all memory is created equal. Stack, heap, registers, segments, memory map registers, memory app files, non-volatile RAM. Systems programming, that's what this is. All right. It's important to know the difference between variables, values, and pointers. So value is a type and the domain of values. Okay. A value is stored in a place, the stack, heap, or a number of other locations, if you have a memory map file, for example. So the difference between a variable and a pointer, well, he's distinguishing between variable and pointer. I would say a variable can hold a pointer. Let's see. Or is he saying that a value is a variable? Most common place to store a value is a variable, which is a named value slot on the stack. Yeah. A pointer is a value. So a pointer is a value. It can be put into a variable. Holds the address of a region of memory as opposed to holding the data itself. I'm not quoting this verbatim. I'm just going through here. Okay, so I get this. I think this is actually really good. This is really succinct way to explain what the thing that he's explaining here is a really succinct way to explain it. I'm not going to, like I said, I'm not going to bring up every paragraph of the book here. I don't want to do this too often. I want to respect the author here, but yeah, I think he's talking about the difference between types and values and pointers and stuff, and I think it helps to have a little bit of background in computer engineering as opposed to software engineering, but computer engineering meaning the electronics of it, to understand a little bit about how the bits exist. But I think just his explanation is pretty good. Let's see here. So I do a lot of JavaScript, and in JavaScript, all primitive values, I think I'm using the term correctly, are just values, and all object values are references. So when you pass in the number 2 as the variable I from one function to another, you're passing a copy of the number 2. When you pass an object, you're passing the reference. And what this means is if you change the number 2, if you change I inside of a function, it doesn't change outside of that function because inside the function it's operating on a copy of the number 2. So it increments the number 2, becomes number 3. It's only in that function where it's operating on the copy. Whereas with an object, objects are passed by reference, meaning that it's not a copy of the object. It is just a pointer, essentially, to the object. And if you change the object inside the function, the change is available outside the function. And that's something that can trip people up. The difference between a reference, which in the purest sense, a pointer is the purest reference, versus a physical value. I don't know how to say it. Yeah. Okay. In the high-level model, we don't think of variables as places that hold bytes. Instead, we think of them as just names given to values as they are instantiated and moved and used throughout the program. Interesting. There's a term that I've never heard before, a flow. Let me see if I can read enough to give the definition of the term flow. I have to back up a little bit. In this model, a variable only exists so long as it holds a legal value. You cannot draw lines from a variable whose value is uninitialized or has been moved, so effectively it isn't there. Using this model, your entire program consists of many of these dependency lines, often called flows, each one tracing a lifetime or particular instance of value. I've never heard the term flows before, so I'm not quite sure that I grasped exactly what the term flow means from that, but it related to the lifetime of the data. Let's see, dependency line. Maybe he's going to give an example in the code down here below. Okay, so it sounds like flow is maybe somewhat specific to Rust in the way the compiler looks at memory access. So the compiler in Rust is pretty advanced in terms of it figures out what the execution paths of the code are, and if there is more than one flow that allows mutation of a variable, then no pass go. Okay, so I'm going to see if I can go just to this page 4 here and just give you some sample code. Let's see. Let me just go to the sample code here because I think this is valuable. I'm trying to not show too much of the book, but I think yeah, because like I said, I'm writing a fine line here, trying to not violate copyright or anything, but also want to point out things that I find useful. So you could not access this because there's no flow. You can't draw a line from any real value to this x because we don't know what x is yet. We don't even know what type x is. So the compiler is checking in this way. Yeah, that's cool. It's good to learn the vocabulary of how to speak about this. One of the difficult things about coding, we talked about this before on the Discord channel, but you've got caching, naming things, and off by one errors are the two biggest problems in programming. And naming things is hard because we have to have a shared vocabulary, and sometimes that vocabulary changes between languages. Because as software engineers, we should have our vocabulary should be really concise and clear. But because of the way that community works and branching communities, people use different names for different things. And so it's nice to know what something is called. I know now that this is called a flow. So when I'm speaking to another Rust developer, I can say flow. And if they don't know what it means, then, maybe this guy's just making up the term flow and then everybody's going to believe that it's a real term. But it doesn't matter. Now we have a way to name this thing, to be clear about it, the way that the compiler is checking things. Oh, and one thing I love about Rust is shadowing. So shadowing is basically, if you want to, hold on, let me finish reading actually. Yep. Okay, so shadowing is basically, sometimes you have a variable that is a particular type. So say you're going to get user input. The user is going to input something into a form field or on the command line, and they're going to input a number. Well, because it's from the command line, what you're going to get is you're going to get a string. You're not going to get a number. You're going to get a number in a string. You can need to convert that string into a number. So if it's age, so let age equals, you read some input, you get, say, 42 as a string. Well, then what do you call it when you parse it, right? So now you have let age int equals 42 as opposed to let, or maybe you call the first one let age stir equals 42. This is obnoxious. And so in Rust, the way that they do this is you redeclare a variable. Redeclaring a variable is allowed, and then you can reassign it. So you can do let age equals the string 42, let age equals the int 42. And so that's the use case I find for it to be the most interesting, or the most useful, most common. Okay, so the low-level way to think about variables is basically being summed up as it is a value slot. It is a slot for something to go. This would, in this example, you can't really think of this that way because you don't even know what type it is. But if you were to add a type annotation onto this and say, let mut x uint 32, then you could consider it a slot because it has a defined space. You know how many bytes wide it's going to be. So whether it's a pointer, you know how many bytes wide the pointer will be, or if it's a number, or you could even have a string of a certain size or an array of a certain size that's exact, that is static, that's not changing. So you could just, in that case, you can think of it as a slot. That's not a technical term. That's just a metaphor he's giving. Okay. And then he makes a side note, because when you get down to the low level, you got to think about like I said, computer engineering as well. So the CPU has registers, and data fits into registers on the CPU. It's where so the CPU can operate, it uses instructions. So CPU has an addition instruction. It has registers that can hold so many bits or bytes wide, and you can say, I want to take what's in register 1 and what's in register 2, and I want to perform the add operation on them, for example. And so, that's a little bit more low level than we really ever think about as web developers, but it's important to know. And he just has a little side note in here about that. Yeah, and he says you got to understand both the high-level view and the low-level view when you're working in a language like Rust. Okay. Stack, heap, and static memory. I'm not too clear on what stack. He's talking about memory regions. Stack is memory that grows as your program runs. Heap is memory that grows, but in a predetermined way. If you know how many iterations of the loop are going to happen, you know how much memory is going to be used. Or every time you recurse, you know how much more memory you need to add on the stack. Stack is about fixed sizes, predictable sizes. And then the heap is for things that are of an unpredictable size. If you wanted to read a file into memory, you'd have to read it into the heap, because there's you cannot know ahead of time how big the file is going to be. You could specify, I'm going to allocate, this wouldn't work on the stack, but let's say that it could. You could say, I'm going to allocate 1 gigabyte. And if any file is less than 1 gigabyte, it can go into it. And if any file is more than 1 gigabyte, then the program crashes. So that doesn't really make sense. So heap is where things that are of an unknown size will go. And then static memory, I think, refers to anything that is in the program itself. So typically, when a program loads, so say, for example, you have error codes. They're strings. They're just user messages, things like that. They go in static memory. They're referenced at the beginning of the program, and they do not change. They are read-only, or they might, yeah. So when they're referenced somewhere else, they're either copied into the stack or they're referenced from where they exist, but it's static memory that is constant, it's not changing. Oh, and stack frames. This is a term that I'm not as familiar with. I mean, I've heard it a lot, but it's not something that's in my daily parlance. Each time a function is called, the memory that's allocated is called a frame. Near the bottom of the stack is the frame for the main function. Okay, that makes sense. So the segments of the stack are called frames. Again, feel free to ask questions or troll me, whatever. I'm not keeping as close of an eye on the Discord, but I am trying to keep an eye on the chat here. I wish he had a visualization for this, an actual diagram. That's my piece of feedback. I'm going to note that real quick. So I'm just going to put this, I'm going to create a private channel for myself, or maybe I'm just going to open up an email draft. What should I do here? I think I'll open up an email draft because I have his email. He's, reaching out to people that are doing early reviews of the book and whatnot. And so he messaged me on meetup.com and said, hey, I saw that you're going to do a book review on your meetup. Please give me any feedback. So I am. I'm going to say I really wish that this had, let's see, Rust for Rustaceans feedback. I mean, this is not meant to be, he's not meant to teach people here this thing. He's trying to give people a refresher, really. But I think, oops. If he's going to go that far, you might as well. Even if it was hand-drawn art. All right, let's take another sip of focus. You know you're approaching the sip boundary as it starts to burn. If you tear up, it might have been more than a sip. Maybe. Okay. Okay. Stack frames and lifetimes go hand in hand. This makes sense. Duh. Yeah, okay. Yeah, I really like this analogy here. I'm going to read this sentence. Any variable stored in a frame on the stack cannot be accessed after that frame goes away, of course. So any reference to it must have a lifetime that is at most as long as the lifetime of the frame. That's just a perfect way to think about Rust's garbage collection. And it's not really garbage collection, but it is in a way. It's not garbage collection like Go or JavaScript, but it is garbage collection that the compiler is inserting the drops for you. It is not dynamic. It's compile time, but it serves that function. Also talking about if you want a value to be available between threads of execution, you have to put on the heap. You cannot store, something that's on a stack cannot be accessed by a different thread. This makes sense. I guess technically you could, if you want memory corruption in C, if you wanted to write a buggy program that crashed in C, you could reference memory on a different stack from another thread. But logically, in terms of if you want a correct program that runs, you can't do that. So you got to put it on the heap. If you put something on a heap, it doesn't have to have a constrained lifetime. Lifetimes are a thing in Rust. It's kind of what it sounds like. We kind of already talked about it, but just how long a variable lives before it's let go. Okay. And a memory leak is when you put memory in a place that if you put memory on the heap and you do not do something to make sure that it is gotten rid of, that is a memory leak. Oh, interesting. Oh, so I think in static memory might be... Okay, static memory is really a catch-all term. Okay, because what I was saying, what static memory was, is not what he was about to go in here with this last paragraph, talking about memory leaks. And sometimes you want memory to leak. You don't want memory to be reclaimed. For the lifetime of your program, you want this array to be available, and the array may grow or shrink in size. If it only grows, then you have a leak. But you may not ever want to reclaim this memory in whole, but you may want to retain. Sorry, you want to retain something for the lifetime of the program, and then it's not a memory leak. It could still be. You could have something that grows to too much memory and then your program crashes, but that may actually be the desired behavior. You just don't have enough memory. Well, I think that he's giving a really good instruction, recap here, but it also may be because I've learned this stuff in the past. Okay, so just talking about the static lifetime. So if you want something to be around forever, you mark it as static, and then it will be in that block of memory at the beginning of the program like I was talking about before. Static is often read-only. It doesn't have to be read-only. You could have static memory that is of a fixed size that you could change what is in that size, but where the static memory is, you cannot grow beyond that size. That would be a corrupt program. That's how you get viruses and rootkits. Not rootkits, but root. That's how, one of the ways that you load arbitrary code into a memory place and blah, 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 blah. Okay. Okay, so I'm going to read this too. Let me see if we can bring this up. This is on page 7 now. This is just one of my pet peeves. I haven't read the paragraph yet, so I'm either going to be validated or I'm going to be challenged, and I may have to come off my high horse. But let's read this together. You may wonder how const differs from static. The const keyword declares the following item as a constant. Constant items can be completely computed at compile time. Constant items can be completely computed at compile time, and any code that refers to them is replaced with the constant's computed value during compilation. A constant has no memory or other storage associated with it. It is not a place. You can think of a constant as a convenient name for a particular value. This, ladies and gents, this is what a constant is. So again, this is my rant against the JavaScript community and co-opting words. What's up, Honene?
I'm gonna saw our chair.
Saw? What chair?
The blue one.
The blue one?
The round one.
The round one?
We're getting rid of it.
Oh, the fluffy puff thing? The marshmallow seat?
Yeah, say sayonara.
Wait, you're throwing it away?
Yeah.
Are you going to saw it outside or are you going to saw it in the living room?
We'll see.
I would suggest you saw it outside, por favor. It's, you're cleaning up the mess, so whatever you want to do. Yeah, we got this thing off the neighbors. I'm not going to argue with her on, well, obviously I didn't. If I really wanted it, I would have been like, no, don't delete it. I mean, yeah, throw it in the trash. But it's a chair that it's sometimes fun, but it's probably more inconvenient than it's worth. So, yeah, sayonara. Okay, let me check comments real quick. I dropped my comment stuff here. Uh-oh. Your conviction on the usage of Const grows stronger. I feel like this the way that you phrase that sounds like something from a video game, and it sounds like it could be in Pokemon. AJ used Const. Conviction grows stronger. AJ used reference book. AJ's conviction is concrete. All right, what do they say when it's a critical hit? Is that what it is? AJ's confidence is a critical hit. Okay, where was I at here? Yeah. And because I'm an old dog, so somebody pointed out to me, which I'm not sure if I buy it, because Rust is a complex language. It just is. But that's the trade-off is you get the power of C with the safety and reliability of a high-level language, right? So you get the literal power of C, not a ratio. So Golang is, what is it, 90% is as fast as C in certain situations, and so you have a guaranteed loss from C with every dynamic language, as far as I'm aware, and with all compiled languages that have a garbage collection in their runtime or that run on a VM. So you just have guaranteed loss. There is no guaranteed loss when using Rust. But I forgot what my actual idea was. Oh, so ownership. But Rust has concepts that exist in no other language that I'm aware of, such as ownership and lifetimes. These are not words that people use in other languages or flows, as far as I'm aware. Lifetime, maybe. Because lifetime does have a generic sense, but lifetime has a precise meaning. It's a single quote and then a name. That is a lifetime. There's the concept of how long will something live, what's its life cycle, I think is what we typically say. But the concept of a lifetime is specific to Rust. And so I, as part of the old guard, I say, well, Rust would probably be difficult for somebody who's new to programming to learn because there's all this extra stuff. But if you're new to programming, then you would not know that the stuff in Rust is extra. It would just be, oh, this is how I program. So, and there's lots of useful programs that you can write in Rust without having to learn too much about the heap. So there's just like in Go, there's a lot of useful programs you can write without having to learn channels. I think there's plenty of Go developers that maybe have never used channels or use them so infrequently that they have to rethink it every time they do or something. I don't know. But I think you need to be familiar with all of Rust concepts to write most useful programs. But there's some, say, trivial programs where you don't, maybe. Anyway, ownership is just this idea that it follows the flow. It follows the flow and the lifetime of the value or the reference of the variable. Sorry, the variable. And if there's a conflict where the streams get crossed, the flows get crossed, so to speak, the compiler yells at you and the code doesn't compile. So if your Rust program compiles, you're guaranteed to be memory conflict free. You cannot have a race condition. I think, is that the right term, race condition? Okay, and Rust, again, Rust and JavaScript share this idea that the default behavior for primitives is to copy the value. So you think about it, it's cheaper to copy an integer than it is to copy a pointer. Well, it's the same cost whether you copy an integer or you copy a pointer to an integer, but using a copy of an integer versus using a pointer to a copy of or a pointer to an integer, you have a higher cost in using a pointer. So particularly for things that are really small, where there would be a higher cost to put something on the heap and have a pointer to it, you just want to make a copy of it. Well, in some cases, you can have references. You can have references to earlier frames in the stack, and you can change values of earlier things that are in earlier frames of the stack. They can be mutable. That is entirely possible. So you don't have to have it on the heap. It's just a typical example. Okay. Yeah, but you cannot. So something that's copyable, you don't have to worry about the ownership, because every time you use it in a different function, both functions own a copy. But if it's not something that's easily copyable like an integer, then if you had two functions both believe that they owned it, then they could both write to it and you could get corruption. Yeah, and so in Rust they call freeing dropping, because it basically happens automatically as a result of the compiler understanding that the lifetime of the variable has ended. Okay, I'm going to bring up another code example here on page 8. Just zoom into the code example. So this is how we allocate on the heap. So Z is a tuple. Tuples are nice. So essentially a tuple, if you're looking at JavaScript, a tuple would be when you create an array that has different types of things inside of it. You just want them to be grouped together, but they're not of similar types. So typically a tuple is not something that will grow in size or shrink in size. A tuple is a fixed size. But for example, it might be, you don't want to create a full object for something and have to access it by name. There's just 2 or 3 values, typically very small number of values. Tuple, I think, refers to 2. It's not spelled 2 as in, it's spelled TUPL. But anyway, the point is there's a number of values that are highly referenced to each other. And let's say that there was a lot of places in our application where we had name and age. So you could put name, which is of type string, and age, which is of type int, into a tuple. And then you could access them as the 0th and first, or I want to call that not first, but because first, 0th and first sounds wrong. Because yeah, anyway, but you can access them as index 0 and index 1 on the tuple. So you could have z.0, z.1. Anyway, so now we've got what? So z exists and then it goes away. X1's value is a copy, so is not moved into z. Got it. Y's value is not a copy, so is moved into z. Okay. Now this is interesting because I thought, yeah, so the ownership, every time there's a new block, so it starts a new scope, every time there's a new block, there's new ownership. So it's not just functions. I said functions, but it's actually blocks. So this one moved into here, and then when this block ended, because yeah, it gets dropped because we moved it into the tuple. I don't know if we had just referenced it here. That might have been okay. I'm not sure. I still, I struggle with the lifetimes and the ownership stuff. Rust is a language that makes me feel dumb, and that's a good thing. I need to be humbled. There's some rules where something you'd think it would be moved, but it actually knows that it's no longer in use anymore, and so then it will let you use it after. I remember seeing it. I don't remember if it was a presentation or something. No, it was code. It was Nathan Stock's Rusty game engine presentation. There was something where he was using a value that I thought would have been moved, but then he said, "Oh, there's this new thing in the compiler, and now it can detect these certain conditions," and then. And so you can use this when it knows that the function is done with it or something, or the block is done with it. Okay, and because this was moved here, so Y1 is moved into this scope, and then the scope ends. So there's the compiler looks at this, and because it's been moved, the compiler inserts. There is I don't know if it's a drop keyword or if it's a function. I don't remember. But you can manually drop things, but the compiler automatically inserts the drops whenever there's a drop. I almost would prefer that to be, or maybe not almost, maybe I actually would prefer, I think I would prefer there to be tooling that just auto inserts the drops for you as part of the tooling. Because that would be a little more explicit and it might help me learn a little better. But anyway, let me see. We got another comment? No, we don't. Okay. Okay. Variables, including function arguments, are dropped in reverse order, and nested values are dropped in source order. I don't know exactly what that means. Huh. Okay, interesting. So that when it drops them, this is a technical implementation detail, but when it drops the values, the reason it drops in source order is because if you have a container and the container is dropped, then each element in the container will be dropped. So you can't drop an element first and then drop the container, because then the container would have a form of nothingness, and that's not allowed by the language. So it's not it's a technical constraint of the language, of the way that the code, because I guess the compiler generated code still has to pass the compiler's rules, and so you couldn't drop a value that is still referenced somewhere else. So I don't think that this matters in terms of performance or anything like that. It's just, would the right word be semantic? I'm not sure, but it's just a technical detail. Huh, interesting. Cool. All right. Hopefully, reading this will inspire me to do my next little project in Rust. I'm thinking one thing that I want to do, that I was just going to do in Node because it'd be quick and easy, is to create a little tool that takes my text files, parses them, and then produces the text in the correct format to copy and paste onto Twitter and into the chat, etc., etc. And I was thinking I'd do that in JavaScript, but I do want to be writing more Rust as well, because at some point I want to be a real Rust developer, but I'm just kind of waiting for the ecosystem to get a little bit more evolved and some of what I consider kinks to be worked out. Not everybody would consider the things I consider to be kinks worked out, but I like working in high-level languages. And I think that there's things that can be solved and will be solved by the ecosystem becoming more mature, certain libraries becoming more mature, certain patterns becoming more solidified as this is the right way to do it. The very fact that this book has come out, to me, means that the ecosystem is evolving to about, it's getting really close to the place where I could feel that I could get a lot of value out of writing in Rust regularly. One of my... It kind of stinks in a way, because it's nice to be early in on something, because then you get to write some of the libraries that other people use, and you get some of that notoriety when you're participating in a language early on, which I enjoy. I've enjoyed that in Node, and to some extent in Go, although I haven't been as prolific in Go, but I've certainly enjoyed it in Node. But to me, the trade-offs haven't quite been right. So, I'm the leader of the meetup, but I don't program in Rust very often. I have programmed paid work in Rust, but anyway, talking about shared references now. That's the section I'm looking at. You can only have shared references if it's read-only. Okay, the assertion in listing 1-4 should never fail. Where's listing 1-4? Oh, it must be on the next page. Yes. Okay. It's a little confusing because, well, that's how it goes sometimes, That's the way the physical paper works. Yeah, shared references must be immutable. What? Listing 1.4, I don't think it quite makes sense. Hold on. I'm going to look at this a little longer. Input is a reference to an I32, and sum is a reference to a mute I32. And we want to store the value of the dereferenced input basically times 2 to itself in the sum. And then, but I don't understand why this would be called cache. It's multiplying by 2. Sometimes I get confused. If you make your example super arbitrary, it's a little sad. You know, if it has to be foo and bar and baz that you're dealing with. But when you use words that seem that they should mean something and they don't, that's where I get really confused. So we have cache, input, and sum. Sum is obviously when you take two things together, but what we're storing in sum is not adding two things together. We're actually storing the multiplication of two things. And now I don't remember what this was supposed to actually represent. So I got distracted. So I'm going to pick it and make a note about to the author here. I'm storing it in an email draft. So I'm just going to put here, listing 1.1-4 is more distracting than illustrative. And maybe hopefully I'll clean these up a little bit. But what was I supposed to learn from that? The assertion in listing 1.4 should never fail. What is the assertion? That what's stored in sum. Oh, okay. I get what it's illustrating, but I was confused by the naming of things. What it's illustrating is simply that if we have shared references inside of a function, we have a guarantee from the compiler that some other thread could not modify those references. Okay, I got that. I'm on board with that. I'm going to close my blinds. It's getting a little darker outside. Okay, totally get that. 100%. It's just it just needs to be a better example so that the example itself isn't distracting. Whether or not the compiler chooses to apply a given optimization is more or less irrelevant. The compiler's heuristics change over time, so you generally want to code against what the compiler is allowed to do rather than what it actually does in a particular case at a particular moment in time. And this is a solid software engineering principle. That's just this is one of those things I want to screenshot. What is this on page 10? Let me get to page 10. The deed is done, huh?
Yeah, nobody survived.
There were no survivors. Oh, well, I guess I'm not that sad about it. So this is just highlight that. That's a software engineering principle there. Because so many times JavaScript libraries have become, and this is stupid because it's JavaScript, right? The JavaScript libraries have risen in popularity because they take advantage of some specific, say V8 specific feature or bug or whatever for that specific revision. And they say, oh, look, we're twice as fast. And then all these blogs become popular about how you can use a minus equals instead of a plus equals, or run your loop in reverse, or do something that's generally a stupid thing to do that just makes it more difficult. And then, not have a comment or anything about, oh, we're targeting specifically Chrome version 55 and 56, and because we have this deployed in the field and because it has this bug, we're running our loop in reverse, right? It's just, oh, I found out that you can run a loop in reverse and it's faster than if you run it forward. No, this is retarded. Don't do this. This right here, this is truth. Truth. Okay, mutable references. The alternative to a shared reference is a mutable reference. That's kind of a good terminology here, because I would say mutable and immutable reference, but it's okay. You can share just one. Your share size can be 0. I can share between 0 and infinity, right? So it is either a shared reference or it is a mutable reference. That is mutually exclusive. That's a nice way to talk about it. I like that. Yeah, mutable references are exclusive. Okay, now this function is called noAlias, and it has input and output. And the output is mutable. Okay, and again, it's just another example similar to this one with memory corruption. The function name seems weird to me. I don't get maybe this is supposed to demonstrate some sort of common use case. I don't get it. But why would you call a function noAlias? I don't know what that means. It's just not a term. I don't know what the use case of this function would be. Because if we call it foo, that's fine. If we call it cache or noAlias or something that sounds like it has meaning, it's distracting. Okay. This may be easier to understand with an example, so consider listing 1.6. A mutable reference. Okay, this is one of those things where I have to think. Okay, I'm going to bring this up. This is something I need to talk through just to help myself better understand it. Not that one. Here we are. So look at this. So I get this. I get this entirely. So what we have is an immutable 42. Right? And for those of you that don't know, this is one of those things that everybody knows. The reason the number 42 is used so often is because it is the answer to the ultimate question of life, the universe, and everything in the Hitchhiker's Guide to the Galaxy books, which is just something that every American geek reads by the time that they're 15. And so it's become part of nerd culture. Okay, but anyway, so we have this immutable 42, which is x. So x is immutable. Now we can take a reference of x. So we're not taking the value of x. We're taking essentially a pointer. And we're saying let mut y is equal to a pointer to x, but the pointer is mutable. Okay, so this is the point where... This is where a foo bar example is a little tough for me because you're dealing with a very specific type of... this is where context would be really helpful for me. So y is of type reference to I32. Okay, so y is of type reference to I32, but y can be changed. Y can be changed, but I don't know that... We can't change what x will be, but we can change what I will be. So right now we're assigning I to the pointer of x, not to the value of x, if that makes sense. Okay, then z is of type reference, mutable reference to I32. And so this right here, where putting the mute on one side versus putting the mute on the other side means a different thing. This is where I get a little bit, this requires some muscle memory. This requires some getting used to, because in different languages, keywords are used in different places. In Go, for example, types are in the more natural position, which is on the left, because at least in English, when we think about things, the first thing, well, actually in English it's not entirely true, because we often use adjectives before a thing in English. But that's not the way that our brain necessarily perceives a thing. It's the way that we speak about a thing. But so the red car, but red is not what's important. Car is what's important, right? And so the typing it's really an annotation. And so in Go, typing comes after. And so here, this is a case where in Rust, mute can come before and it can mean one thing, and mute can come after and it can mean another thing. And so this is where I'm actually a little confused as to how I would use these three. And let me see if I can scooch along to another example. No, that doesn't. So this, I'm gonna put. I want 1.6 to be a more relatable example. Yeah, Douglas Adams. Did I say someone else? I don't think I said the author's name. You're just saying the author's name. Okay. Yeah, Douglas Adams. So L16 is too generic for my taste. Can we get some context around that? All right. So, all right, I'm going to try. This is the thing where if you want to be a Rust developer, this needs to make sense to you. It just needs to make sense to you concretely. And I've heard from other Rust developers that it is somewhat of a muscle memory thing. It's not that you can, it's not necessarily that if you don't intuitively understand it, that you can't get it, but it is that by doing it, you start to recognize the pattern more. But for me, this is just really tough, just looking at this. So let me see here. All right. So this X is immutable. It's not the 42 that's immutable. It's not that memory location that's immutable. It is X that is immutable. The variable is immutable. And then with Y, we are saying that Y is mutable. So I could change Y to be a different pointer. It is or a reference type. It is a reference type. It must be a reference to an I32. Not a copy of an I32, but a reference to an I32, int32. So a 4-byte wide integer. Okay, so this makes sense. Y is mutable. Now here, Z, this is where I'm a little bit confused. Okay, Z is immutable in this case. But it is an immutable reference to a mutable. It's a reference to a reference. It's a pointer to a pointer. So I think this is just, again, for me, what really helps, and I hate this because I do this too in my own presentations, because I'm trying to demonstrate a concept and then I drop the context to focus on the concept because it's one of those catch-22s. It's just really hard to create good examples. But my question would be, how in the world, what would be, I understand how I'd use X. I could add it, I could multiply it, it could be somebody's age. I don't understand what the use of Z would be. I understand how I'd use Y. I'd understand why I'd use Y is if I wanted to share this reference somewhere else, then I would pass Y around somewhere. But the reference is not mutable. Y is mutable. And then here, I think here we're actually transferring ownership. I think we're transferring ownership of Y to Z. So I don't think that we would be able to use Y again. Let's try this out. I just want to see if my hypothesis is correct here. Let's just try this out. But this is one of those things where it would be ideal. Obviously, you need to try out code to learn code. But it would be ideal for me if I didn't have to even try this out. If I could just... let me bring up the playground. If the example was so clear that I didn't have to experiment, I would be more pleased. Because I'm going to forget my experiment unless I take notes. Not playlist. Playground. Rust playground. Okay. All right. So if I just plop this in here. So I forget, what is it? Println. Is it like this? Am I doing that right? And then we need to pass in, if I remember correctly, it's brackets and then x. I think this is how we do it. So x should be fine. X is not moved. I'm taking a reference to x, but x itself is not moved. Y, I think, is moved, but I'm not sure. Because I don't know if the and mute and 32 means it's a reference of a reference, or if it means that it's a mutable reference. Okay, but let's just run this and see what happens. I think what's going to happen is that I'm going to get an error that I can't print y because y has been moved. The ownership of y has been taken over. Okay, good. Wait. Yeah. Mutable borrow occurs here. Immutable borrow occurs here. Mutable borrow used later here. So if I did not use z, whoops, I think the compiler can actually tell, well, actually, since you never use z, the mutable borrow could just as well can be dropped right here. It could essentially infer that it can drop it on line 5. And then I think this can work. Let's see if that's correct. Yeah, so warning, unused variable z. But we don't get an error. Okay, so that's the case here. Is that since I'm never using z, I'm getting a warning that I'm never using z, but since I'm never using z, it knows that I'm done with z before I begin. Another thing that we could do is this. If we put this in a block like that, now I could be wrong here because this might get moved and then dropped and then drop y entirely. Nope, unused variable. Okay, so now if I go back and I print z, well, when I can't print z because z is now gone, but let's just move that here. Okay, so this works, interestingly. So I think maybe the book is actually already out of date in the sense that even though, yeah, I think the book is actually out of date. I think that when this book was created, because I just referenced an example like this on the other page, right? So when this book was created, if you were to move y, then it's borrowed or what? No, because this is a borrow. This is not a move. This is a borrow. Because we're doing a borrow. So the borrow is done when it drops out of scope. Okay. All right. Okay, but what is z then? What did we print out? 42, 42, 42, 42? So is this a double reference? And there's a way to do a debug. I forget how do we do a debug. Rust debug print. Because I like to get the type information and everything. It's a question mark. The print pound question mark. Is that how we do it? Question mark, question mark, question mark, question mark. Okay. So let's take this colon question mark and see if that will do. Now this is a macro. So I think this might give me more information. I don't remember. No, it's just going to be whatever. I think for objects it prints out more stuff. Anyway, I'm a little confused about this, but I'm going to move on because I think if I move on, I'll do better than if I just continue to focus on this one example. But I did want to try it out for myself. I really would like, this is something that I need to bring up with my Rust friends and say, hey, explain to me this. You know, why specifically, wait, where did it go? It's over here. Let's go back over here. So I'm going to screenshot this for bringing up the meetup on Thursday. Why is this just not and mute I32? Why is it seeming to be a double reference? Anyway, maybe if I just read the next paragraph, maybe it'll explain it. Okay, let me see here. Okay. It explains it here, which is kind of like what I said. So notice Z itself here is not mutable. So I'm going to expand this just a tiny bit more. I think this really does need, for me, this needs a little bit more love. But again, maybe it's because this is not really focused at Rust beginners. But let's say this is A and this is B. Okay, so we can do this. We could even do y is equal to and b, because y itself is mutable. Then we could say z, and then I guess we could do z. What would it be? Z is equal to and c. Let's create a c that goes to 44 perhaps. Oops. And then maybe we could print, we don't need an x here, we just keep with our y. So this would be A. So it is a reference to a reference. Just a lot of dereferencing. Let's see, will this program run? No, of course not. Because it needs what? Something's missing. Here, we're missing a semicolon. There we go. Okay, so 42, 43, 44, 44. So we can't change Z, but we can change. Okay, so it is a double reference. It is a reference to mutable. Got it. This is just one of those things where I don't know. My brain may not be cut out for it because I struggled. I don't know. Maybe everybody struggles with double pointers. That would. But we can't. So we can change the value of y, but we can't change the value of what y is pointing to. So if y is of this type. Okay. All right. I think I get it now. I think I get it. I just need just that much more. Okay. Primary difference between owning a value and having a mutable reference to it is that the owner is responsible for dropping the value when it is no longer necessary. I mean, here's a tough one to take in. If you move the value behind the mutable reference, then you must leave another value to take its place. If you did not, the owner would still think it needed to drop the value, but there would be no value for it to drop. Another code example here. So yeah, there's just another layer here where you're looking at it, you're transferring ownership of memory just as much. Ownership is a first-class citizen in Rust. what the responsibility is sometimes transferred with the value. Well, if it's not a reference. And I think the box, if we box something, so let's say we did this. If I did box new, now box just means I'm putting it on the heap, right? That's not so hard to comprehend. And then in that case, I don't think that I need the ampersand. I could be wrong. But I don't know if this would work either. So I want to get, what do I want to do here? I can't dereference this. I can't dereference this to take its value because this is the owner. A is the owner of the value. So if I try to dereference the value, maybe I get a copy of the value? Let's see, what happens here? Oh, expecting a box value. Okay, got it. Moving on. All right, let's see. What else we got? All right, I've made it to page 11, y'all. It's been an hour and a half. I can tell that I'm definitely going to make it through all 200 pages before Thursday. I can tell. Yeah. So you can't, the reason you can't, do that as a result in a double free. Okay. Okay. Yeah, I definitely say this, it's obviously geared towards people that are doing Rust a little while and they're trying to understand more of some of these patterns and some of the under the hood stuff. I think if I programmed Rust more often, then this would make more sense. Let me go back over to here for the moment. Or go back over to the book in question. There's another code sample, but I don't know that it brings much more value than this, so I'm not going to go to it. Oh, and a bot to block. So, hello for those of you joining in. I'm A.J. O'Neill, and I'm just studying right now. So you can see me testing some things. I'm reading comments out loud. I'm not going to show you everything that's in the book because, respect to the author and his copyright, but little certain snippets I'm bringing up. Okay. Unsafe cell is the only correct way to mutate through a shared reference. Probably because it has mutex stuff. Well, you use mutex stuff, right? Well, mutex. So you can have a mutex and a ref cell. I mean, these are things I haven't used. Okay. And so you can have shared writability through essentially a container. So the container you can pass around, and it has a mutex inside of it. So you can have these atomic values because internally they are consistent. Called safe interior mutability. It's not shareable across threads. Unless it's in the mutex one. I think so. Ref cell, not shareable across threads. Okay. If you're reading this book, you're probably already familiar with the concept of lifetimes. Likely through repeated notices from the compiler about lifetime rule violations. Oh. The upside is that, yes, the compiler can teach you how to write the code. As we've seen in the playground, it gives very good error messages. A lifetime is really a name for a region of code, meaning visible region, that some reference must, and could be code calling other code, that some reference must be valid for. While a lifetime will frequently coincide with a scope, it does not have to, as we'll see later in this section. Yeah. At the heart of Rust lifetimes is the beloved borrow checker. The data flow mental model we discussed earlier in the chapter. Compiler checks that the flow of the reference we are accessing does not conflict with any other parallel flows. Lifetime does not need to be contiguous. I don't think that's what this example actually shows, but okay. Oh, I think it's just saying, so for example, you can have an if block where you use a variable in one, an if else where you use the variable in one branch but not the other branch. I think that's what it means by contiguous. So you can use it here and then you can use it there and then not use it in the intermediary case. That to me that just seems obvious, but okay. I need to get my jacket back on. It's getting cold in here. Oh, I need to delete more stuff. Uh-oh. Oh, can I share the book revision? Yeah, that seems to be right in terms of... Oh, is it 280 pages? I'm going to be so screwed. No, this one's not 280 pages. This one is 252 pages. But this is the first print of the book. It just came out. So November 2021, yes, that seems to be correct. My ISBN is 9781718501850. Yeah, matches. So that would be, but this book is new. There are PDFs online. If you find a pirated PDF, which of course I recommend that you pay the author. Saying that as I have a pirated PDF up on the screen, but I'm using this just as a as a reference. If I found a lot of value in reading the book on a computer or a tablet, which I don't, then I would be happy to buy it. But this is just for this scenario. Anyway, but there are variances in the book. The early preview access copies, some of which are circulating, and I don't. Maybe this is one of those. I don't know. I took the name of the book and I didn't even do anything nefarious. I was just looking to see if there were samples on a website. I just put the name of the book into a search and it came up with, PDF copies. But again, I think, as with most things, you're going to do what you're going to do. If you're a high school kid, you're going to pirate it because you got no money. If you're a working professional, you're going to pay for it maybe twice. Once as a PDF, once as whatever, because it's worth it to you. To me, there is, yeah. I stop being cheap and buy some paper books. There's value to having a hard copy. I agree. And I've also, you got to get rid of the mentality. Think of it like this. You think of it more like a hamburger and less like a book, in the sense that this is your book and you're not trying to preserve its value. So, bend the pages, use the highlighter, et cetera, et cetera. In fact, let me take my own advice. I'm going to go get my highlighter and I'm going to start bending some pages on here too, so that when we get to the meetup, I can ask some questions. Well, I don't know. I don't know if it's actually worth it for right now. I think these are more stay flag, stay. Okay. Let's see. Yeah, if I find something I need to highlight, now I've got my highlighter here. But I think of a book more like buying training. You buy it, and you might gift the book to someone else at some point in the future, or you might throw it in the rubbish bin. It's fine. The purpose of the book, you go to see a movie with your family and it costs you $30, and you get, for the family cumulatively, you get 2 hours of enjoyment out of that $30, right? And that's the end of it. That's what it is. Maybe you made some memories. You get to talk about it. If you want to look at it a different way, you could say, well, out of that $30, we got 6 man hours of enjoyment, because you count each individual's enjoyment as separate hours. However you want to categorize it. And a book is the same way, or a video game. Just imagine. You get 400 hours of enjoyment out of Breath of the Wild and you only paid $60. Wow. That's a steal of a deal. If I get so much training out of this book, it's consumption cost. Wait, he will give the PDF version for free. Wait, is the author? Oh, no, this, you pay. Download chapter 1. Okay, so you can download chapter 1 for free. But yeah, if you want the ebook. Wait a minute. Print book and free ebook? What? Oh, it's 280 pages because it's counting all the title pages and all the pages that aren't actually part of the book. That's why it says 280 printed pages. Okay, got it. Yeah, where's my free ebook? That's okay. I got my free ebook right here. All right, I'm completely justified now because I see that I should have received a free ebook with this, but I whatever. Oh, sorry. I bring this up on the screen. Yeah, free ebook. There we go. Yeah, so I'm entitled to this. It was not given to me as it should have been. Yeah, sometimes Amazon gives you the raw deal. I've learned with video games, don't ever buy on Amazon if you can avoid it. Buy on, was it GameStop? Because if there's anything that's supposed to be included with the game, you'll get it through GameStop, but or Best Buy even. But you'll often not get it through Amazon, which really ticks me off for pre-orders where, because I did the pre-order, I should have gotten the daggone extra material, but then on Amazon you don't get it. But if you get it at Best Buy, you will get it. And often Best Buy's still in stock when Amazon's out of stock. Anyway, that's a completely different thing. All right. You need a more rigorous mental model to work with in terms of lifetimes. Okay. Let's see. So don't use my affiliate link to buy this on Amazon. Buy it from No Starch Press so that you get the ebook that's supposed to come with it. Daggone it. I pre-ordered it on Amazon. I got nothing. All my friends that pre-ordered it from No Starch Press, they paid the same price or lower, and they got early access PDFs the whole time. Bah! Amazon. Brr. Okay. Okay, so just reading this part now about lifetimes, basically it's saying if your code can be inspected at compile time and it can be determined that because you execute one branch of code, you obviously did not execute the other branch of code, and one branch of code extends the lifetime of something and the other branch of code does not extend the lifetime of that thing, then you can follow the rules as if the other branch of code didn't exist for whatever happens within that branch of code. I think that's what it meant by lifetimes do not need to be contiguous, as in the lifetime in one branch of code can be different than the lifetime in another branch of code because it knows that the lifetime must end if one branch of code is selected because the other branch cannot be done. And that's what we looked at earlier, where we did a little scoping problem. We moved Y, but then Y remained accessible. Or I don't know if move is the right word. Lifetimes can get quite convoluted. In listing 1.9, you can see an example. Oh no. I think this is going to be worth bringing up. Oh, maybe, maybe not. Let me read this a little bit, and I'll see if I want to bring this example up on the screen or not. Huh. Yeah. Some of these things, again, I just need more code experience to really make sense of them. Let me go back here. Is this the one? Am I looking at the right one here? No, I think it's looking at this one. Okay. So it's saying, so this is lifetime A, and this is lifetime A, and this is lifetime A, and this is lifetime A. So at the point here, when X I'm not really clear what this is saying. But it essentially is saying there's a different Z. So this Z, this reference to X is used, but here that X is gone. But it's okay because we're not doing a print line of Z here. We're doing a reassignment of Z. And so it doesn't matter. We can add more stuff to Z because Z is mutable. We can change its reference, but we would not be able to print Z. And I'm gonna test this out. Let's try this in the playground real quick. But I think I understand this. I think I understand what it's saying. There is a beauty to Rust. There really, really is. It's kind of, when you just look at it, some of these nitty-gritty technical details, it seems like a real headache. But there are some patterns in Rust that are just so smart that they really make it worth it for a lot of people. All right, so this is, oh, no, this is wrong. Okay, so what I want to say is this, so this code should run, and it should work. Good example. Yep. Okay. Bloop. But now let's do this. This code, I think, is going to break. I could be wrong. Let's see. Why would this code work? This code would work because this box is gone. This box is basically dropped every single time we go here. So this box could still exist. I'm not sure. I'm not sure what's going to happen. I'm not sure if it's going to run or if it's going to fail. Yeah. But hey, my initial thought, you heard it straight from the mouth source. My initial thought is that it was going to fail. So I was correct. Huzzah. Brownie point for me. I win. AJ versus Book. Book 10,000. AJ, well, I guess it's not really AJ versus Book, but we both get a point. So is it possible to load a Python library in Rust? The reverse. Python is essentially written in C. So when you write Python, people don't write Python in Python. They write Python in C. I don't know if that makes sense. Anything useful in Python is written in C. But it turns out, because you can export Rust like C, you can write Rust that then can be used in Python. So you would not import a Python library into Rust. That would not make sense because Python is this dynamic language that needs a runtime. But what you could do is you could export a library that was written in Rust to be able to be imported into Python. So, if that makes sense. I hope that was helpful. Oh, is my chair down again? My chair is down again. Let's lift my chair up a little bit. Is my chair sinking? I'm looking at my picture to see if my head is going below. There's the browser window. Am I sinking? I don't know if I'm sinking. You're welcome. Yeah, and everybody feel free to ask questions. I'll do the best I can to answer them. All right. But the problem that I have here, there's something about this that's not clicking in my brain. And again, maybe it needs to be the muscle memory. I should be able to look at this code and I should be able to know why. Why did I know? See, I'm having a hard time articulating exactly why did I believe that this would not work? Because it references a value that at this point no longer exists. But why? It's a reference to X. Okay, this is where I'm confused because again, we're doing basically a double pointer. So a box is already a pointer. And we're taking a reference to essentially a reference. That's why I was a little confused, because what we're saying is we still have this reference to X, which is this box, but we're creating a new X, so that should get cleaned up right here. Because now that X is being replaced, what was an X before is essentially being dropped. That's why I thought that this would turn out this way, and that turned out to be the correct belief. Okay. What I need is to buy something that just upgrades my brain. But I guess, again, it's muscle memory. It's not... I don't think I've talked to anybody who said, you know what, Rust just made sense to me intuitively. I think it's more Stockholm Syndrome, where as you deal with the abuse of your captor, you grow to love them. No, that's not. There really are great things about Rust. It's just you have to get through this additional mental modeling. And it changes. As the language evolves, the compiler gets better at being able to predict code branches and such. So you have to be less explicit about lifetimes and whatnot. And that also is a little bit of a trick, because as you're learning how to do this, the compiler is being programmed to do it better as well. And so some of the things that you're learning become not necessary, but in a good way. But it also, again, I don't have enough experience with it to fully challenge my understanding. So do you still recommend Learn Python the Hard Way as a good Learn Python 3 the Hard Way, because there's 2 books, as a good beginner's book? I'm going to say yes and no. It depends, because I think that Learn Python 3 the Hard Way is good reference material. It is a good way to learn to program. I don't like Python as a programming language, but that book is a good book to learn to program. So I'm going to say yes. I still recommend that. And if you happen to be doing a job that Python does well, I'm not really clear what that would be, because basically everything that Python does well is done better by either Go or Rust. But, well, neither one of them are quite as good at burning through money on AWS. If you just got investor money and you need a way to make it disappear, Python is a great way to do that. But the investors don't care, so it really is a great way to do that. And specifically, if you use Python for machine learning, it is so incredibly inefficient. It's just, fairly, again, when we're talking about machine learning at the level of essentially Excel macros, when you're talking about, well, that might be a little too derogatory. It's not that. It's because pandas and FB Profit, it's standard statistical analysis stuff, but it is not something that would go into an Excel macro. It is, but it's written in C. It's not written in Python. It's just you use it from Python. Anyway. The borrow checker is and has to be conservative. If it's unsure whether a borrow is valid, it rejects it, of course. As a consequence, allowing invalid borrow could be disastrous, of course. We don't want corrupt programs. Borrow checker keeps getting smarter, but there are times when it needs help to understand why a borrow is legal. Oh, this is part of why we have unsafe in Rust. Yeah, I guess because you, as the programmer, can know I know that this code path, if if this condition's met, this condition will never be met, or vice versa. But going back to the previous thing, don't write code to be readable. Okay. Oh no, generic lifetimes. Ah. Okay, because the Rust programming language, the other book that I was holding up, this one, says, because this one covers the basics of lifetime in detail, I won't do that here, and I don't fault him for that. So here's the basics. So this is hilariously true from not my own experience, but from people I've talked to. This book, this is the intro to Rust. This is the basics, okay? But once you've got the basics down, here's the advanced stuff, right? Okay, so he recommends going to that book, and that book is free, available. You can get it on the official Rust website or through the same publisher. I think they just released a third version of it. I have the second edition here. I think the third edition just came out. Oh, bless me. Interesting. Interesting. Okay. So Rust automatically implements these drops, essentially freeing memory, or more or less. So if you implement the drop trait, meaning that you have some sort of cleanup code, if you call so wherever you drop it counts as a use of it, which makes sense. So basically, if you want to be able to drop it, it has to be around for you to drop it. If it's already dropped, it can't be dropped. I think that's what it's saying. So it's a subtlety, but it makes sense. I think it's because the implementation of drop has, typically it's not just letting go, but it's doing cleanup. I think that's what when you implement drop, that's what it does. So in order for it to go out of scope, it counts as a use. It's interesting. A type can be while a type can be generic over multiple lifetimes, making it so often only serves to unnecessarily complicate your type signature. Yeah, probably. Usually a type being generic over a single lifetime is fine. And the compiler will use the shorter of the lifetimes for any references inserted into your type as that one lifetime. Oh, this is making my head hurt. Again, I need the muscle memory for this. Okay, we're gonna look at this. I'm gonna make your head hurt too. You thought we were friends, but wait until you see what I show you next. All right, here it is. There we go. All right. So we have a reference to a string, and we have a reference to a document, and these can individually have different lifetimes. So we're going to iterate, and we're going to implement an iterator. And then what is this? Function string before character option string. Let's put document delimiter. Next. Okay, let me see. But wait, why is there a lifetime P here for document? I'm really not sure what that means. I'm going to be honest. I'm going to try reading this paragraph and see if I can understand. So we've got a document and a delimiter. Okay, let's see. What's the problem here? Trying to understand. So here's a struct. We're going to give it a document, and we're going to give it a delimiter. Okay, I'm on board there. And the delimiter is a reference that we're turning into a string. Okay, so that's a reference to a string. Got it. Oh, okay, because it's a single character, and we need to make it a string so it can operate on string functions. Okay, we're going to call this next. So immutable reference, immutable reference. Okay, the to-do here is maybe throwing me off a little bit. I think what they're saying here is that an item, any item, is going to be a segment of the document. I don't know why they use S and P. I wonder what's that convention there. Okay, but the item oh, is this a type alias? I think this is a type alias. Okay, so it's going to return self. It's going to return a reference to itself. I'm not quite sure, because what you get back from this really, I'm not clear. I'm not clear on what's going on here, because self item, okay, so self item because this type is only defined inside of this implementation, and it's an option because there might be one or there might not be one. And I wish this to do was filled out with even some pseudocode here. But I'm assuming that what's going to have to happen is that we're going to search through the string for the delimiter, and then we're going to return essentially, this is not the appropriate word in Rust, I don't think, but a slice. We're going to, memory bounds of the string. So the string needs to last, let's see. I'm not sure. I'm not sure why this needs multiple lifetimes. When this is done, we don't really care about the delimiter string. Once this is over, once it's finished its work, if we never call next again, we can just be done. String before. I don't know why it's called before. Again, I get hung up a little bit on what context are we getting from the example. All right, let me read the paragraph again now that I've inspected the code a little bit. Josue, hello, I'm back. Paid by the C gang. Wait, what? Paid by the C gang. Hello, I'm back. I missed whatever that reference was. Look, when my brain is overloaded with this type of context, I don't have frivolous cycles to spend on your references to things that I might get otherwise, or if I'd looked at the chat in the right time. All right. When you construct this type, you have to give delimiter and document. Okay. You have to give the delimiter and document to search, both of which are references to string values. Yes, agreed. When you ask for the next string, you get a reference into the document string. Yes, agreed. Consider what would happen if you used a single lifetime in this type. Then we would never be able to drop char. And since char is not a reference, I get it now. Okie dokie day. Because char is not a reference. It's a character. But because we're creating a reference to it, then the value that we would need, this is going to be dropped because this is a copy. And so this is a reference. I got it now. Okay, I get it now. I get it now. I get it now. I just needed to read it slower. I needed to look at the code, to evaluate it, to understand, even though the to-do there was throwing me off a little bit. But now I understand why this makes sense on its own. Okay. Okay, so let me continue to read. All right, the values yielded by the iterator would be tied to the lifetime of the document and the delimiter. This would make stir before impossible to write. The return type would have a lifetime associated with a variable local to the function. The string produced by toString and the borrow checker would reject the code. Oh, whoops. I read that with the wrong emphasis. Okay, I get it now. I get it. In fact, this may have been gold in terms of me now understanding a critical something that I did not understand before. So this, again, I get a little thrown off by the names of things. So why is this called stir before? Because I'm thinking that it's going to... I'm unclear. What is this supposed to be, the first string? Is that, or am I, because I'm just creating an instance of this and I'm just getting the first next and then it's done. And then, oh, by the way, Rust has implicit returns. If you don't put a semicolon after something, then it returns. I think this is stupid. Just putting that out there. I think this is dumb, but it's what they decided to do. I think that the return keyword is much more clear and that we shouldn't have to have semicolons. Having semicolon mean don't return is tarded. Capital arted. Just lowercase t, capital arted. It's tarded. But it's what they chose to do, whatever. But it's just confusing. If you don't want this to return, put a semicolon. All right. Okay. This book was worth its money right now. If I don't read past page 15, this book is worth $40. Boom. Okay. Now, can I remember that? Can I remember that and then put it into practice? I don't know. Maybe this was an emotionally traumatizing experience for me. I think I'll remember it for the rest of my life. Okay. All right. All right, lifetime variance. Oh, no. Why do you want to hurt me? Oh, variance is a concept that programmers are often exposed to, but rarely know the name of. See, naming things, it's hard. Because it's mostly invisible. At a glance, variance describes what type are subtypes of other types, and when a subtype can be used in place of a supertype. No, it's too much meta language. I can't do it. Gosh, if I learn Rust and I use it, I'm going to be a programming god. Oh, man. Just so many things that you have to keep in your head. Or maybe you don't. Maybe it's like learning piano, where it feels impossible. It feels as though it's going to break your brain to use both hands at the same time. But then I never got past that point because it felt like it was going to break my brain. But people do. And then they're able to do it really quickly. So maybe it's one of those things. Again, muscle memory. Okay. Oh, broadly speaking. Oh, good. A type A is a subtype of another type B if A is at least as useful as B. What? If it's at least as useful? I feel that the word useful needs to be defined in this context. Variance is the reason why in Java you can pass a turtle to a function that accepts an animal if turtle is a subtype of animal, or why in Rust you can pass an reference static stir to a function that accepts a stir. Okay, I get that. I'm going to go cry myself to sleep tonight. While variance usually hides out of sight, it comes up often enough that we need to have working knowledge of it. Turtle is a subtype of animal because turtle is more useful than some unspecified animal. A turtle can do anything an animal can do, and likely more. Okay. Similarly, static is a subtype of, quote, static, lifetime static. I'm just going to say lifetime for the quote mark. Is a subtype of static A, or lifetime A, because lifetime static lives at least as long as any lifetime A, and so is more useful. Okay, sure. Okay. Got it. So for any lifetime, so if you have two lifetimes A and B, if B lives longer, then B is the one that's more useful. Okay, got it. Yeah, all right. I don't know where this is going. Oh, there are three kinds of variance: covariant, invariant, and contravariant. Oh, okay. I'm going to bring this up on the screen real quick. This is cray-cray. All right. So, is this the same? All right. So, just cry with me. Three kinds of variance: covariant, invariant, and contravariant. Inverse, converse, and controverse, right? Okay. All right. If a variable is of type static AT, you can provide... No, not static. Lifetime A. Okay, reference of lifetime. But what is the difference between lifetime and reference lifetime? Or we're just saying it's a variable, okay, of any type, but the reference... Okay, so here's a question I have, and we can maybe find this out, okay? Maybe we can, maybe we can't. I don't know if I want to come up with an example for this right now. This is what using your brain is like. It hurts. It hurts so bad. This is why people don't do it. It's painful. It's physically painful. Okay, so I'm just going to ignore that for a second. So why do we have... Would there... This... Are these different? That's what I want to know right now. Let's do this. Fn foo, and we're just gonna take we're not gonna return anything. So we're gonna take in a reference to an I32, and we're gonna print it. What is this? Wait, which way does it go? It's this, isn't it? It's similar to how we do in Go, right? All right. So I think this is going to be valid once I get rid of the garbage up top. All right, so we're going to let a equals 42 foo a. I think this should run. It's unnecessary to specify the lifetime here. Lifetime in a trait object must be followed by plus. Wait, let me go back. It's just because I forgot how to write a function, that's all. Nope, it's not. That's correct. Okay, I don't think I'm going to do this. Let me try one more thing. So what if I get rid of this and I do this? Then does it run? This is what I'm trying to figure out. Oh. Use of undeclared lifetime name A. I don't know. I give up. I'm going to move on. I guess I have to try this with traits to get it. I mean, I'm using it wrong, so I guess it makes sense that it's wrong. Okay. Okay, I get what the point that he's making about covariant here. Oh, good vocabulary lesson. So something is invariant. Basically, if it's mutable, it's invariant, meaning that you can't do a substitution. So if it's covariant, it means if you have a long-lived lifetime, you can pass in a long-lived lifetime in places where it was expecting a shorter-lived lifetime. It's okay because it lives at least that long. But the mutability, this is not true because of the mutability rules. Okay. Contravariance comes up in function arguments. Oh, wait. Yeah, pass in. Okay. Okay, so when you're declaring a type, it's okay to have something that lives longer than what the type needs. When you are declaring a function, well, let's see if he gives an example. Oh, okay, I get it. Yeah, so if you're declaring a type, something that lives longer can be passed into places that live shorter. But if you're declaring in a function, then something that lives shorter is more useful than something that lives longer. I get that. Okay. So he's just defining these technical terms here. Okay, I kind of get that. Although I would have a hard time, I did have a hard time back in geometry and then later in relational algebra, memorizing the definitions, the strict definitions of co, intra, inva, and contra. Did I say that right? Yeah, because there's the positive, contrapositive, inverse, counterpositive, like that stuff. It just gets confusing because mirror can mean two things. Well, it could mean more than two things, right? So a mirror image could be that one image is left and the other image is right, but it also could be that one image is upside down and the other image is right side up. So you need to have different words. Mirror image is ambiguous. You need to know which side you're mirroring on. And that's what these words are. They're that level of distinction. They're saying they are mirror images. Whether if you use it this way, then the shorter one's more valid. But if you're looking at it this way, then the longer one's more valid. It's all saying the same thing. It's just whether you're looking at it from the perspective of this block or that block kind of thing. I think I get it. Okay. Oh, good. There's another code example. Okay. I've got a mutable string struct, and it has a mutable string A or S. What? The mutability of the string has lifetime A, but the reference of the string generally has lifetime B. I think that's what it's saying. So we want to make a mutable string hello, pass in the mutable string, and then say, what? Yeah, I'm confused. Dang it. The examples just being so daggone simple in terms of their shortness makes them more difficult for me to understand because I really need the context. I keep saying that, but it keeps being true. Yeah, this example is incredibly contrived. So let me show you this example here. I don't think that you would ever write code like this. I think the code is written explicitly. This is it. So in the last 10 minutes, I've scrolled down one paragraph. Excellent. So this just is so incredibly contrived. Because you would never write code where you would create something and then throw it away. So it's illustrative, but without the context, I'm confused as to what it's illustrating. I would feel better if it was written out a little bit longer, and then with a comment, this is where this thing starts, and this is where this ends. Well, let me take the code into the playground. Let me do what must be done. So I've got a buddy that's trying to get through the Rust book right now. I kind of want to troll him and just be like, you know what? You just should go straight to this. Don't worry about that one. This is the book you really need. Oh. All right. So let's just first verify the code runs. What? Wait. This code is supposed to run, right? Oh, maybe a struct shouldn't be defined within main. I guess it's valid. Let's check the errata as well. Does the errata have something different about this? Okay. Oh, whoops. This is wrong. Okay. So now the example works. So what I want to do is, can we break this down? Can we say, whoops. Oh, what happened there? Can we, I'm just going to call this MS for short here. And then ms.s. Or is this going to fail? Okay. Interesting. Interesting. So this actually has to be on one line. So that was only semi-contrived, and that it was being thrown away immediately. So if I wanted something with this signature, which again, I'm not advanced enough to actually understand why I'd want to use that signature, but if I had something that needed that signature, I actually have to declare it this way, where I give it a mutable reference to S. And then assign S to it before it gets assigned over here. What? So a reference to a mutable reference to S, because this is a mutable reference. And then I need to assign the string to S because I'm dereferencing it here. Hold on. Let me see if the reason that I got this wrong was this. So let's try this again. I'm going to comment this out. Is that it? Okay. All right, what does this mean? I'm reporting this stream for mental abuse. Mental abuse of who? Of me? Are you going to report that I'm abusing myself? Because you have you can opt out. I'm in. I'm committed. Oh, thank heavens. Only a little bit. What are we? 2.5 hours in, and I am almost through the end of page 17. That concludes chapter 1. Heaven help me. Oh. Okay. All right, I'm going to read, now that I've redone this, all right, so what I have is a container that has a mutable string. I guess the mutability and the string have different lifetimes. So the mutability of the string is one thing, but the string is originally mutable, S. The variable is originally mutable. And then I'm giving it a reference, a mutable reference to S. And then I'm creating a different string. But then the thing that makes the teamwork that makes the dream work is to print out S itself, right? Because we've got mutable S, and then we're taking a mutable reference to S. and S is mutable, which means that we can change what's underneath of it, yeah? So we're going to strip out hello right from underneath of it. And we're going to, oh, whoops, that's in the wrong order. I knew that. Can't. So the mutable borrow, the string lasts longer than the mutable borrow. So this will work. Okay. This is chapter 1, y'all. Chapter 1. It only gets easier from here, maybe. Oh. Okay. The syntax may seem alien. No. No crap, Sherlock. All right, so I think the reason that he did the example the way that he did with this right here, which I totally disagree with, because it's syntactically valid, but it's useless. I don't believe that there is any use for this. He's writing it this way so that it can be dropped immediately, so that there's not a warning for an unused variable. So he's doing this. This is the type of thing that I would not recommend that you do in the real world, especially not for an example. Because in order to avoid a warning, because the compiler will warn if you don't use a variable, but the compiler won't warn if you do something that is essentially a no-op and then drop the thing before the variable exists. I mean, it's not really a no-op because it is updating this mutable reference. Well, no. Then why not create a variable for it? Because it's going to get dropped all the same. Yeah, this is something I'd never recommend doing because you're shortening out something. This is something the language allows. For what reason? Who knows why? There might be a valid reason why you'd want to allow this sort of thing. I can't imagine what it would be, but it may be that making it invalid would invalidate something else that is necessary to be able to do. But just don't write code like that. So I'm going to put listing 111, L111 wouldn't it be more clear to just create the variable? Is there any case where this alien syntax would be useful? Okay, that's my note there. I should have done the advanced copy of this. I really should have. Because then I would have been able to contact him and maybe before it got printed and make some suggestions like this. I don't know. Maybe he would have disagreed with me. But this just seems overly obtuse. Okay. Let me continue reading. Maybe I just need to finish the paragraph and then maybe it'll be explained why this would actually be useful in the real world in some scenario. Hey, what's up, Kai? Oh gosh. I read that in maybe the wrong way, but hello from the park. I've lost my child playing it cool. When I read lost my child, which is what my brain parsed first is the most important phrase out of that, I thought death. And then nothing else made sense. Go find your child, Kai. I just started learning Rust 2, checking out programming idioms to learn faster. Okay. Hey, Al. Nice to see you. Hey, and tons of people have been coming and going. I should have said this a couple times already, but if you find this to be useful and or entertaining, give it a thumbs up. Otherwise, give it a thumbs down and share with someone that you don't like. But if you do like it, share with someone that you do like. Okay. Again, so I need to finish this paragraph here. When we later attempt to access the string. Okay. Huh. Oh. Okay, so I think I get it. This seems kind of weird. I don't know if I'd want to write code this way. I'm not, advanced enough to get to say. Okay, so this whole piece is describing a lifetime, and this whole piece is describing a lifetime, and this is the type. So it's a reference lifetime and a mutable reference lifetime. But again, then I'm confused as to why, because no, reference with lifetime, which is mutable, reference with lifetime, which, and then no mutability, and then type. So this is one thing, this is one thing, this is one thing, this is one thing, but it includes this. So yeah, so we have two references here. So one is a mutable reference, and the other is an immutable reference. And the mutable reference doesn't have to last forever. It must be mutable. It must be a mutable reference in order for us to mutate it. But then if we're not doing any more mutations, then when we go to do this print line, it's okay to have two references to this same string that are immutable references. So if we're guaranteeing that they're immutable references, so basically it's saying, I want to have a mutable reference to this, but I don't want the mutability of the reference to last. It only needs to last until we decide that it doesn't need to last. So this allows us to have something that is immutable for only a time, and then for the rest of the time. So I would not be able to mutate this again, is the thing. Okay, so if we have this, and I could be wrong, but I think this is going to prove to be true. So once the mutable reference is, doing this would extend the lifetime of the mutable reference. It would extend the lifetime of the mutable reference past this. So now we're going to get an error. Yes. Got it. Okay, let me get rid of this thing. Can't you put an air tag or something on them? Air tag on what? I don't know what an air tag is. Oh, air tag on oh, okay. Yeah, so you need to put the /s on there, Jay. and air tagging the children. Got it. Yes. Make sure all of your children are microchipped and vaxxed. Okay, programming idioms lets you compare a language you already know and has good explanations to stuff with other reference. I'm going to screenshot it and leave it in the Discord to show you. That'd be great. Yes, would appreciate that. Thank you. And for those of you that are joining in and leaving and whatever, if you do want to be part of the Discord, I'm going to drop a Discord link here one more time for you. And I think my wife might be texting me, so it might be time for me to end this soon too. Let's see, what in the world? No, let me see what this is. Okay, listen. Okay, got it. Yeah. All right, so BT dubs. So we have a little boy. He is 3 months-ish now. And we are doing a baby blessing at church tomorrow, which I am, as the father, I am doing the baby blessing at church tomorrow, which is it's a really simple thing. It's just, me and a couple of friends, we're going to hold the baby out and not hold him out, but just hold him and basically say a prayer in which that I announce his name. It's not like a christening or anything. I don't need, it's more of a conventional thing. It's something that we do, I guess, to celebrate children, that celebrate birth and new life and whatnot. But the reason that I brought that up, because it's actually one of my church buddies it's a group that I don't know. I went on a tangent there. Anyway, the point being, regardless of how I got on the tangent, is just that I have a son and I am formally giving him a name tomorrow. As far as obviously he has a birth certificate, he has a name, but, for the records of the church, which again, it's not a christening. It's not, it's a relatively small and simple thing. They happen all the time because people have babies all the time, and it's just done as a short little 5-minute thing at the beginning of church, usually once a month for all the newborns that have past the date where they're back out in public again. So typically around 2 months or 3 months or so. Anyway, just a little tidbit of my life there. Okay, so let's see. I got to finish this paragraph, finish this chapter, wrap this up, and I don't. Goodness knows how many more of these do we have. How am I going to do this? 13. What if we multiplied 13 by 3? I'd have to do a heck of a lot of streams studying this book. See how far we get. I think I'm probably just going to do a couple streams between now and Thursday doing the studying of the book. I'd kind of like, what do y'all think? Let me know what you think about studying the book on air like this. Is this a good format? Is this fun? Yeah, let me know what you're thinking about that. Because I think I'd like to continue it. It's kind of fun for me, but I'll only get through a couple chapters and we'll do the book review. Other people have read the book the whole way through, so I think I'll be able to contribute something. I might need to skip around, do a couple of different chapters, things that I'm most interested in, rather than reading it from front to back. As he says, it is intended to be, it's put in a coherent order that you can read it front to back, but it's also intended to be reference material. So I think that could work. I could maybe do another 2 chapters, and then we'll have them meet up on Thursday and we'll do the book review. And if you want to tune into that, just let Google Utah Rust YouTube. And it is youtube.com/Utah Rust. So I enjoy watching you struggle with Rust as much as I struggle with JavaScript. Solidarity. I think that's how that works. Okay, and you found him. That's great. I'm going to put air tags on the kids. Oh, we were talking about kids. That's part of why that thought process all got brought up too. Yeah, cost of AirTag, $99. Cost of recovering your child, priceless. Brought to you by MasterCard, Goldman Sachs, Apple. Just for fun. All I've got is a paragraph left, and we're done with this chapter. But heaven knows, I can't maintain focus long enough to do that. I'm out of focus. Sips of focus. That's not true. I've still got a little in here. Let's see. AirTags. Oh, it's a 4-pack for $99. Totally worth it. Totally worth it. Now, how do I get this into the child? All right. Okay. I'm going to finish this paragraph here. Okay. All right. So he makes a good point here. So he redeems the absurdity of the example somewhat, and that he says this is an example where adding additional lifetimes makes something complex, and so you have to consider the ergonomics of, is the complexity really worth it, or is there maybe a different way to do it that would be less complex and more ergonomic? All right, summary. What did we learn today, folks? All right, chillins, let's check it out. Summary. Wow. Oh. So I just everything up until lifetimes, I think, yeah, sure, I get that. The aim of this chapter has been to establish a solid shared foundation that we can build on in chapters to come. By now, I hope you feel that you have a firm grasp on Rust. It's like somebody teaches you quantum physics in a 30-minute lecture and then says, and so I hope you have a firm understanding of quantum interactions. It's just, man, by now I hope I have a firm grasp on it too. Thank you. Oh, okay, we got to clip this. I got what's the time cut? 2:56. I have to send this to oh gosh, I'm blanking on his name right now. He's got his face in his mind. Spencer. I got to send this to Spencer. Oh, I got oh yeah. Okay. I don't know why. All right. And that those errors you may have gotten from the borrow checkers seem less mysterious. You might have known bits and pieces of what we covered here already, but hopefully the chapter has given you a more holistic image of how it all fits together. In the next chapter, we will do something similar for types. We'll go over how types are represented in memory, see how generics and traits produce running code, and take a look at some of the special type and trait constraints Rust offers for more advanced use cases. Woof. I'm out, y'all. Oh, left the screenshots in Discord. Okay, let me bring this over real quick. All right, we're done with that. We're gonna do a little bit of answering comments, and then I'm gonna go. I don't know, pee myself and then cry myself to sleep. Okay. Oh, okay, cool. Yeah. Great. This is awesome. Programmingidioms.org. A+ recommendation. You want to put a comment for this on creedsofcraftsmanship.com and just link that. This seems to be a really great resource. And then what's this other one? Oh, whoops. It's doing some Gazzo here. Oh, same thing. Yeah, this is awesome. Yeah. Thank you for that. Thank you so much for that. That was just great. Thanks, must be Al. Okay. Smother the air tag in peanut butter. I'm just a pet owner. Don't do not mention about raising kids. That's how we get the air tag inside the child. The problem with that is that the air there's two problems with that. There's two major problems with that. One is that the air tag will go out of the child. The other is that the digestive juices will corrode the battery and kill the child. So I would not recommend that method. So we're going to have to rehashtag this with parenting advice. Oh, this has been so fun. Thanks, Kai. Well, Jay, for just the whole time you were bringing the laughs here. Really appreciate it. And Kai, thanks for coming in and added to the humor. That was really appreciated. These are not good outcomes for the air tag. Okay, I don't know what's putting me in this mood. It's probably just being frustrated. But this is great. I've loved this. Thank you so much. Really appreciate it. To everybody, thumbs up if you got them, thumbs down otherwise. I look forward to hanging out with y'all again. You have a good one, but I need to go. I need to go take a break. Do some light smacking my head with a hammer to relieve some of the pressure. I'll catch y'all later. Maybe I can do another chapter tonight. We'll see. All right. But all that said, peace out. Adios.